games. So that's good. This is good. Don't make the math easy, at least for game B.
Flip, I think it should be A for the first one, or B for the
Because you lose 50 cents sometimes, right, Aria? You're playing game B?
No.
Oh, there should be no negative point fines on game A.
Wait,
Oh God. Oh sweet Jesus. Sweet Mary, Mother of all Holy. Now what I'm going to do is I'm going to collect some data. Let me turn the camera so y'all can see it at home. I'm going to go to that side board.
spring, summer, fall.
Okay, zoom in a little bit here. Got my glasses on, so what the hell I'm doing. Okay, I think that's gonna come in focus, we'll see.
Okay, you badasses, it's time to collect data. You don't have to do this on your warm-ups. But I'm going to come around and visit with each of my teams because I have to find out what happened. So what I'm going to do is, I'm going to do game A first. Game A, there are 3 different payouts, correct? There are 3 different payouts. For game A, let me hear from my game A people. What are the 3 different payouts in game A? If you roll a 7, you win $1. So that's a gain of $1, right? I'm gonna put a positive 1 with a dollar sign there. If you roll an even sum, what's the payout? That's minus $1. Make that red so it jumps out at us. We can also lose it. That's a payout. I guess technically we should call it a payout. Sometimes you pay out. Sometimes the casino pays out. So let's call it payout.
Access to national scholarships.
And game A'ers, what is the last payout for game A? Thank you, plus 50 cents. Is it okay to not have the pluses on there? In the black means positive. In the back, you don't have to put the plus sign, you know it's plus. Okay, good. Thank you. Perfect. Let's go to game B and set this up. You don't have to write this down on your warm-up. We're going to have this on the board to refer to when we flip the warm-up over and do the back page. Okay. Game B. How many payouts are there in game B?
2.
Thank you. What are those payouts, game B'ers?
Plus $1 minus 50 cents.
$1 and a negative 50 cents. So if you win with the prime number, you get $1. If you lose 50 cents. You don't roll a prime number. Beautiful. Okay. And this is important. We have to know that, but we also have to know something else. And I want to get you thinking statistically a little bit. I want to make a column right next to that called frequency. Frequency. Put a line between these two. What that means is, how many times did we see each of these things in the games we played? Is that fair? How many times do we see it? So let me see, can I get one person from each game A group to put your hand up so I can come around and interview you each? If you played game A, stick your hand up. Go ahead, Malay, I'm going to come and use you as a count. What I want you all to do right now, all you game A'ers, look at your results. Tell me how many total times you won $1 in your game. And I'm going to come around and I'm going to add as we go. So how many, from both of you, count for both of you. I want, make one person do all the addition. Malay, I'm electing you. Add up all those positive ones, all those positive ones. Gee, I got it. Good doing. All right, how many ones you guys got? Just one, okay, 1, 1. Okay, how many ones? Just 2?
Our answers too.
Your answers are 2. What does that mean?
Oh, I don't know. Maybe I'm just.
No, how many times do you have a 1 written in your thing? Positive 1. 2, 3, 4, 5. Oh, no, you're doing a running total? I love that, brother. We're doing that soon. So right now, I want to collect the data. How many times was it? So you won, was it 5 ones? 5 ones? Plus, Travis, was you had 1 1? So it's 5 and 1, that's 6. How many ones, Q?
We have the same for we have 4, 4, 5.
There's a, that's a plus 1? 1, 2, 3, 4.
Yeah, we have the same number. 4,
4 video. It starts out with the Beyblade. I think it's like the intro to the show. The guy's like
Oh! You had 4, 4, and 2. You had 4, 4. Okay, so you had 4. Okay. Just tell me the grand total. You have 4 plus 1s.
Yeah.
So 4 plus 5 is 9 plus 1 is 10.
There's a
How many do we have? We had 3, so that's 13. Where's my teammates over here?
spheres.
3 more, that's 16. And then Andrea, how many?
We're not.
Yes.
16. Okay, it's down number. Let's forget it. 16.
But it's, and then it's like,
What do you got? Oh, you're still counting. Oh,
it's, yeah, it was funny as shit. You just hear the person that goes, ah!
You got 3. 3 positive ones, not negative ones.
You know what I'm
Positive
talking about,
ones.
right?
So dear friends,
Like a necklace. Yeah.
we have 19 positive ones for game A. Now we're going to do the same thing. I need game A'ers. How many negative ones did you have? How many negative ones? Come around negative ones now. Trav? 10. 10. 8 is 18. 7 is 25. 35. Love this. 13 is 48. Plus 15, 48 plus 15, 63. Check my math on that. Ouch. Now, we're gonna be clever. Hands up if you were game A, just one person from each group. Hands up if you were game A. Okay, 1, 2, 3, 4, 5, 6. 6 people, or 6 teams, each played 20 games, yes? That's 120 total games, yes? How many wins of 50 cents did we have? I don't need to count, thank God, because that hurts. I don't need to go around and count. We can figure it out from what's on the board. We can figure, give me a thumbs up when you figured out what goes in that box.
49.
Give me a thumbs up. Just give me a thumbs up. Don't tell me yet. Oh, I do want to hear it, but give me a thumbs up if you figured out how to figure it out from this information. You must have played 120 trials. 19 of them were $1 wins. 63 of them were $1 losses. How many were 50-cent wins? Give me a thumbs up again if you got it. Okay, I want to hear it on 3. How many go in this box? 1, 2, 3. 38. 38. Now, who wants to tell me how you got it? That was clever. We all got 38. Why are there 38 there? Please tell me. Who wants to? Actually, talk to me.
Because if you add 63 and then whatever's remaining to get 120.
Whatever's here has to get the sum total to get to 120. If you played game A, you either won $1, lost $1, or won 50 cents. We've already accounted for every other outcome except this one. So this has to be 38. This has to be 38 to get to the total of 120. We'll do that again on game B for practice. I'm trying to get you to think like a statistician. Statisticians go, that's a degree of freedom. I can figure out what that is if I know what that is. Could I have gone around and counted? Yes, but you saw how much trouble that was for me. Yes. You ever ask me that question? Ask me that question. Okay, you don't have a question. Okay, I'm never playing poker with you. Totally misread your face. You all know this? Some of y'all have good poker faces. I'm never playing cards with you. Okay, game A, thank you. Game B'ers, I want to hear from you now. Okay, there should be 5, let me see, 1 hand from each game B group. There should be 5 hands up right now. Just count 1, 2, 3, 4, 5. There they are. Okay, same exact, now, we're gonna start a little bit backwards here. If there are 5 game B groups and you each played 20 games, how many total trials did game B do? 100 even. It's gonna make the math a little bit easier for us. Now, all we know at this point is these two have to add up to 100. I have to know one of them to get the other. So let's figure out how many $1 wins we had. Give me those game B hands again. Where are my game B hands? Okay, game B, how many $1 wins did you have, Kincaid?
6.
We had 6 there. Avery, plus 5 is 11.
6.
Plus 6 is 17.
Wait, did you say number 1?
Number ones, yes.
8 times.
17 plus 8 is 25. Thank you, Savannah.
We had 8.
Shit, I messed up. Let's go back and do it again. This is the problem. This is where my ADD works against me, Jess. Okay, I'm sorry, game B'ers. Give me your numbers again.
6.
6 plus 5 is 11 plus
8.
8 is 19. My bad on that one. Plus 18, that's 27 plus, where's my last game, beers? Plus 15? So 27 plus 15, is that right? 27? No, 27. I'm gonna keep saying 27. How many ones did you get at 27?
Oh, sorry.
It's okay. You got what? 27. 27 plus 9 is 36! Woo! Damn, that hurt. Therefore, how many 57 losses did we have? 64, right? Whatever's left to get to 100. Kind of clever. And you just watch me count up to 36. Let's not make Sean count to 64. Answer the questions right now before we go any further. We understand the data? After looking at this data, which game do you like better? You like B?
You come out with $2.
I like B, yeah.
You lose $32 versus 36 bucks you won.
We lost 32 here versus 36 here.
Well, in game B, you win.
We won 36. Oh, and lost 32. Ah, so Travis is already going down the path that we're going to go to later, which is, okay, good. Let's actually chase that down. Hold that thought, Travis. Give me 20 seconds. Yeah, we'll get into it right about now. Anybody else like game A? There's 2 ways to win, right? 2 ways to win. That's not appealing to you? And Kate's like, dude, yeah, 2 ways to win, but you're not winning very often. And that's where the questions come now is, how did we do on average? Turn your warm-ups over. On the back page, there's a question there that says, on average, how much did we win for game A? On average, how much did we win for game A? So I know we won $1 19 times, we lost $1.63 times, and we won 50 cents 38 times. Like, I know all that, right? I know all that. But the question is, on average, how did we do? Okay, so when you hear the word average, and I gotta move the camera because I think I've now pointed at the wrong word. When you hear the word average, what do you think of, my dear friends? How do you find an average? I bet you some of you have done this before. Practice up a little bit. What's an average?
I'm not.
Is it adding it all together and dividing it by how many times?
I don't even need my keys because you just nailed it. Say it again, Jess.
Adding it all together and dividing it by how many trials?
So no, thank you. So we're gonna be dividing by 120 for game A, right? We're gonna divide by 120. What we need to do first is we have to add up all of our winnings. Okay. That's a different kind of average. This is called the arithmetic mean. Thank you for that. The arithmetic mean. Generally speaking, when you hear the word average, Ariana says a great question. Is that the median? Great question. The average is generally, conversationally, societally defined as what Jessica just said. You add up all the data and divide by how many data there are. So I'm going to put that in quotes here. So you add up all data and divide by the number of data. Has anybody heard this before? Does this kind of ring a bell to anybody? Give me a thumbs up if you've heard it before. Okay, maybe half of you, maybe 2/3 of you, that's good. If not, we're gonna do it right now. Okay, I'm gonna start. Don't write this down. You can tell me to stop at any time.
You can stop.
Okay, why are you stopping me? I have to add them all up.
You already know.
What do you mean you already know? No, I don't. Tell me, Travis. Tell me a more efficient way of adding up all those winnings. This is ridiculous. I could do this, right? I could go 1 plus 1 plus 1 plus 1 plus 1 19 times. And then minus 1 plus minus 1 plus minus 1 63 times. And then plus 0.5 plus 0.5 plus 0.5 38. I could do that. But what's an easier way to do that? Shelby, what are you thinking back there?
Well, it says right there, the frequency.
Uh-huh.
These numbers.
Uh-huh.
Do the math of them.
Say that again?
Do the math of those numbers.
What math are you doing?
Like adding or 19 minus or
Payout times frequency. See, if I have to add 1 19 times, isn't that the same as 19 times 1? Literally, that's what it means. If you add something 19 times, you can also just multiply to get it. So let's do $1 times 19. So 1 times 19 is $19 for this first bit up here. If I lose $1.63 times, what have I lost in total for this row right here? I've lost $63, have I not? That kind of hurts, doesn't it? And then if I win 50 cents 38 times, this is actually kind of coincidental, is it not? What did I just say it again, Andrew? Oh, it was Yusuf Adel. Thank you. I heard the voice coming from that direction. I guessed wrong. Isn't that 19 bucks again? That's a half a dollar. Take a half of 38. So my total winnings for game A, well, average winnings, I guess. Average. I gotta get a new cartridge for this marker. It's starting to die. How do you spell winnings? 2 N's. Jesus. I gotta add up all the data, which is 19 minus 63 plus 19, and divide by 120 games, trials, right? What's 19 minus 63 plus 19? What do you get?
-25.
Negative 25. So we have a net loss. But we're spreading that net loss over 120 games, right? So if we spread it over 120 games, what's our average winnings? Do that math. What's 25 divided by 120?
-21 cents. Rounded.
Rounded 21 cents. So basically, we are losing 21 cents per game on average playing game A. Sucks. Ask me questions right now. I'm getting some looks that are like, I don't like this very much, Sean. I don't like this very much. Got those. Ask me questions. Or do you think doing game B might answer the questions? Maybe. Maybe if we do it again, it'll answer the question. Maybe, Andrea, yeah, maybe. Okay, maybe we just do it again, see the process again. And the good news is, there's an even simplified process, but right now I didn't want to jump right to that. I wanted to make sure we understand what's going on. Let me ask you a question. If, as Jessica said correctly, all we gotta do is add things up and divide by how many there are. If there are 3 payouts, why can't I just add them up and divide by 3? 1 minus 1, 0, plus a half is a half, divided by 3 is a 15th. That's about 7 cents. Why can't I just do it that way? Why can't I just do it that way? Why can't I just ignore the frequencies? Not that they're different prices, because they're different probabilities. Do you think this was a fluke? That this was the biggest number? That wasn't a fluke at all. We're going to analyze why soon enough. In about 5 more minutes after break, we're going to analyze why that is the biggest number. I knew what that was before the game even started. I set these games up this way. Why? Because I'm a bastard. But no, I wanted you to have different. And I knew that this was going to be about twice as big as this. Again, we're going to see why after the break, when we actually calculate these things out using the probabilities and the frequencies. This is messy because you're doing statistics right now. This is a messy time for us. It's messy. A lot of numbers, a lot of adding, a lot of multiplying, a lot of dividing. Let's do game B. Let's do game. Gotta move the camera again too.
You damn kids. All right, let me zoom out a little bit more. There we go. Okay, some of you are in the camera now. I'm sorry. FERPA violation.
Sorry. Okay, game B, here we go. Do we still like Jessica's definition of, black market? Do we still like Jessica's definition of add up all the winnings and divide by how many games we played? I like it. I like it. I think it's great. I think we can do it again. I think, Travis, you already did part of this for us, did you not? Here's game B. I'm going to squeeze this in here. Payout times frequency. Space. Okay, if we won $1.36 times, that's 36 bucks, yes? Yes. If we lost 50 cents 64 times, That's a loss of 32 cents, yes? Oh, I should have been done red. Damn it. Okay, too late. Let's go do game B now. Average. Game B, average winnings. Again, winnings. Oh my God. Let's add up all our winnings. 36 bucks minus 32 bucks. Everybody following that? Add up the winnings line by line. 36 bucks minus 32 bucks. And then how many games did we play all together? Game B played 100 even. Oh yeah, baby. What's the top? 4, and very importantly, it's positive 4, is it not? That's a positive $4. $4 per 100 games, which comes out to what?
4 cents.
That's 4 cents a game. What some of you are like, well, that sucks. But doesn't it suck less than game A? Why? Because it's positive. On average, you're losing with game A. On average, you're winning with game B. So those of you that had that gut feeling that was like, I like game B better, you just measured your gut. That's a good thing to do with math. You measured that gut feeling. Yes. We buying this? Okay, you got that glazed donut look. I think it's time to take 5. When we come back, we're going to learn a more efficient way of doing this. We have to do this math in some way. This has to be done. But there are some efficient ways of doing it if you can establish probabilities, and that's what we're going to come into when we get back from break. Let's take 5 of them. Oh yeah, we're well overdue. I'm sorry. 10 minutes over. I apologize. Let's take 5. Come back. Yes. If you want to drop your warm-ups up here, that's great. Talk to John.
So for the single game, would game A still be better because you have closer to half a chance of winning versus that one you're much lower than half chance of winning with the single game?
Oh, sorry, Carlos. I'm so sorry, buddy. Can you ask that question for everybody's back in the room? Because it's such a great question, and I want to make sure everybody hears it. It's not just about the chance. It's about what you win or lose with the chances you've
All
got.
right, so I guess you have closer to half a chance of actually winning something.
Right. And the problem is, it's almost impossible to play a game one time. You can't. All you can do is look at the probabilities. Like you're more likely to win with game A than game B in one trial. But that bites you in the butt over the long run. So the question is, when you go to a casino, do you walk up to a table and play one game and then walk away? Or do you stay there? Sometimes you don't. Now the difference there, of course, is the casino games are all rigged against you. Every single one of them is rigged against you, even probability-wise.
1,000 on red.
Put 1,000 on red, if you win, you walk away. But the problem is, it's 47.5% chance of winning, 53.5%, 52.5% chance of losing. So, probability-wise, yes. But my brain always goes to the long term. It always goes to what happens if you do something over and over again. Because it's like buying car insurance, right? You don't buy car insurance for Monday. You buy car insurance for 6 months. You know what I'm saying? Now, can you view the 6 months as the short term? Absolutely you can. You can view 6 months as a short term and then change it. My wife does this all the time. She's a genius with our finances. She'll change health insurance, life insurance, homeowners insurance every couple years. Because she starts shopping for different rates and different premiums. I don't have the patience for it, and it makes me nervous because money always made me nervous. But she's like, this is cool. It's like a math puzzle. Like, it is a math puzzle, but it makes me emotional. Brings back childhood trauma. And she's like, yeah, okay, just go cut the lawn and I'll take care of it.
For my personal finance, can you ask her how she does that? Because always, whenever I go look at other ones, they always want, well, sign up and then we'll tell you. It's like, Brett.
She actually has a spreadsheet. If you send me an email, I can probably get it for you.
That'd be super cool.
Yeah, she's got this. She started it like 15, 20, 25 years ago. And it's the most amazing thing. It's this spreadsheet with all of our finances in it, all of our expenditures, all of our earnings, all of the interest we earn. And the top, there was always this number that I go by, and she was working on the computer, and there's this number that was up at the corner. Sometimes it used to say like 15, 12, and then over the past couple of years, it would say like 5, 4, and then one day it said -0.1. I'm like, wow, what's that? I asked her, like, what is that number? She's like, oh, that's the number of years you have to work full time left before our investments start working for itself.
Oh, sick.
I'm like, how the hell do you do that? She's like, you know that shit that makes you upset? I do it.
And I'm like, oh. And then she actually took all the numbers and showed it. And it's the stuff we're going to learn at the end of this course. Compounding interest and how when you stick money into bank accounts, it grows slowly at first, but as you get older, it rockets up. I'm old. We've established that. I'm in the rocket up part now. Like, we've just been so, 35 years of putting money into bank accounts over and over and weathering storms, weathering stock market crashes, weathering recessions. You just keep reinvesting. And so that spreadsheet, which I can get you a copy for you,
I
absolutely.
don't need like your personal.
No, no, I'll give it to, she'll give you the blanks. She's given it to like dozens of people.
Okay, cool.
Because she's like, this is not a zero-sum game. Like, if we're doing this, that doesn't mean you can't. Like, if we're earning money, that doesn't mean that you can't.
Well, I appreciate her not
Oh,
gatekeeping.
dude, absolutely. No, it's not zero-sum. I mean, either way. I wish I had, she's so good at juggling those numbers and spinning those plates, keeping on top of the sticks, and I can't do it. Like, I know the math. And whenever she has like a coding issue in that spreadsheet, she can't figure out, like, oh, let's figure that out, you know? But as soon as it becomes financial, I don't know, a lot of childhood trauma around me, and it just makes me upset, it makes me nervous. But she's like, I got you. Makes us a good team. I can do all kinds of shit. Like,
ADHD thing of like, well, I got the money today, tomorrow that's tomorrow John's problem.
right, and I don't let myself, I can't do that because I worry so much.
I mean, I need to not, but
I know, but it's easy to do. It's easy, especially when you're young, especially when you're young.
things are shiny, shiny things.
See AD coming out. Aren't you insufferable badasses? As you come back in, I'm gonna give you. Now, oh, thank you, yes, I appreciate that. As you come back in, just make your way back in. Every once in a while, I'm going to make you notes documents for class. Because, especially with something like this, there are quite a few moving parts. And I want to make sure that the most important stuff you don't have to worry about getting the wording on exactly right. So I am going to definitely give you.
What do you need from me?
How much time?
Not very much. And it sounds like I'm about to have less. What do you need?
I can't reach your face. No, this is notes. This is what we're going to do the remainder of class time.
Work together on this?
So this is going to be like, sometimes you have to take notes in class, and I've given you plenty of room to do that here.
We did not.
But absolutely,
do it
you were welcome.
together.
Kind of like 98, kind of like Math 98. But a little bit more, a little less given, a little more fill in the blanky kind of stuff. So what we're going to do is, we're going to kind of go through this for the remaining half hour of class. Once you get the procedure, you're going to be like, oh, this is a piece of cake. I got this. This is tedious.
Class when there's not audio video.
This is tedious. And the other problem with it is, the problem with that tedium is that it requires you to have to do the experiment before you can do it.
Everything that happens is allegedly.
But you can establish the averages. You can establish the averages
No face.
without doing the experiment if you can get the probabilities you need. All right, so everybody, take a look at the very top. We're just going to read some of it together. This is probability day 3. We are at day 3 of probability. I'm so excited about this. We're here for 2 more days. Just good chunk of the course. Like a good 25% of the course. Probability. Love this stuff. And technically, it's day 5 if you count the first 2 days of class. Maybe maybe 1. Okay. So, while we're doing it this, I'm going to also
Probably just
have a
go
spreadsheet.
and then I can like prove behind feet.
So, real quick.
Math. This kind of math. In this mathematical way.
Log in.
I usually just do it on my own and then like, how did you work through that? I like my way, so I still get to do that.
Okay, so right here,
And if I'm wrong, then I can figure it out.
because I'm
You
me,
did it right. I go,
and I like doing stuff
why
like
you
this,
were right and why.
I've made a spreadsheet to play the game for us. So this is a spreadsheet rolling dice, just like you did in the warm-up. Keeping track of the sum and then seeing what happens down here. So in game 1, oh sorry, this should be game A and game B. Sorry, A, B, 1, 2, my bad. I'll fix that later. So if you roll a sum of 9, you win 50 cents in game A, you lose 50 cents in game B. We can play it again. Okay, we just rolled 9 again, that's kind of fun. I just rolled 8. I lost $1 in game A, I lost 50 cents in game B. I just rolled a 3. I won 50 cents in game 1. I won $1 in game 2. Okay, that's great, but that's slow. So what I'm going to do is I'm going to let this play out here, if I can. Let this
little button down with a stapler. Is it going? Nope. Is it going now? There it goes. I'm gonna let that keep playing for a while. Is that okay? Let that keep playing for a while. Now, on your notes, let's read through these notes together. Okay? The big idea of the next half hour and the last half hour of our class is something called expected value. Literally, what expected value is it's the amount you're going to earn on average if you do an experiment many times. Like what's just happening right now. Right now, many times, it's establishing. Now, what I'm kind of hiding from you is over here, I'm keeping track of the average winnings after 1,287 games. Game A is at a loss of 14 cents, and game B is at a win on average of 15. This kind of correlates to what happened to us, if you think about it. Kind of correlates, not the same numbers, but negative and positive, right? Just like ours. So I'm gonna let it keep playing while we work some math. And we're gonna learn, and we're gonna let that keep playing. See, it's moving around, it's changing a little bit. It's changing because the data's still coming in. But you can see what's really going on. Game 1 is a total loss, and game 2 is a total win if you add up all those winnings that we did. I'm gonna turn this off. What we're gonna do is, we're gonna learn the procedure for expected value, doing game A, right here in the space for game A. But it says, let's redo the warm-up games, average payouts again. But we're not gonna use the data we got in our warm-up. We're gonna use probabilities. So this is a 4-step process. 1, 2, 3, 4. Boom. 1, 2, 3, 4. First, game A. We'll do game A right here. Game A, expected value. Okay. Step 1 is the same as the warm-up. Identify the payouts for the experiment. That's the same. You have to start there. Game 1, identify the payouts. 1, identify the payouts. Always first. I'm gonna make a little table right here. Is that okay? A little table right here. Payouts. For game A, remember what they were? What were the payouts for game A? Win $1, lose $1, thank you, Kathy, and win 50 cents. You got it, girlfriend. So we're at $1. We got a loss of $1. I should finish writing that. There we go. Loss of $1 and a win of 50 cents. That's the same as it was before. We still have to start with that. Here's where the efficiency comes in. Number 2, if you remember we did in the warm-up, we had to put the frequencies on there. And this is what took a lot of time, because you had to play the game to get the frequencies, right? But we didn't have to do that. Instead, let's look at the probabilities of these things happening. Let's go back to last week. So number 2 is find the probabilities for each payout. Oh yeah. So payout number 1 was win $1. Do you remember what the action was that won you the $1? You had to roll a sum of 7, right? What is the probability of rolling a sum of 7 on a pair of dice? We did this last week, didn't we? It's 6 out of 36, is it not? There's 6 ways to roll 7. Ha! 6 out of 36. So I'm going to make a little column right here, probability, if that's okay. That's the, you can have the whole word if you want to. 6 out of 36. Excellent. How likely is it that we lost $1? What did we have to do to lose the $1? Do you remember? We had to roll an even number, didn't we? How likely is it to roll an even number? Pretty likely according to our results, huh? I got an idea. I gotta pause this thing for a second.
this. I'm gonna do what we did last week. This was somebody's idea last week, I forget who it was. Outcomes for 2 dice. We Googled this in class, did we not? We did. Let me get that picture, open in a new tab. Oh, yeah. Okay, how many total outcomes are there for a pair of dice?
36.
We figured that out, 36. That was in your homework last time, 36. And here they all are. Here's all of them. Do you see those 6 sevens? How many even sums are there? Holy hell, you already got them? I haven't even started counting yet, baby. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's a pattern here. 10, 11, 12. It's a nice pattern. 13, 14, 15, 16, 17. Travis, you badass. Half of them are even. Which I think John said earlier. I believe you said that earlier. Maybe. I remember you saying that. So in other words, 18 out of 36. Are going to lose $1. 18 out of 36. That's 3 times as likely as that, is it not? You're 3 times as likely to get that than that. If you look at your numbers over there, oh goddamn. Look. Isn't this about 3 times as big as that? It's close. It's not perfect. It's close though. If this was 60 and that was 20, it's 3 times as big. It's rad. Okay, you insufferable badasses. What probability has to go in here? Do we have to go back to that chart? We have to go back to that chart and count again? Savannah's saying no. We can be more efficient than that, Savannah, can't we? Because you know they all have to add up to what? Gotta be 36 out of 36. So all we gotta do is figure out what's left to get this. This is gonna be over 36 as well, right? What's left to get us to 36? 12. So this is twice as likely as that, and I can't help but notice that we got twice as many 50s as we got ones. It's actually pretty cool. It's like the dice are falling in a random pattern or something. I love that. Give me a thumbs up if we're okay this far. Okay so far? Okay, ready for the only bit of math you gotta do? This is it. Well, there's 2. We're gonna break it into 2 steps if that's okay. Step 3. Multiply each payout by its probability. Straight across. Straight across. You did this earlier, if you remember. You may remember, we did this with the frequencies. So you're going to take each payout and its probability, and then I'm going to make a little column next to that, if that's okay. I'm going to make a little column next to it. I'm going to do pay times prob. I might need a little help with calculator here. Might need a little help with calculation. If I take $1, and multiply it by 636, what do you get?
0.17 rounded.
Thank you. That's going to round off to about 17 cents. $1 times 636 is 6/36 of a dollar. Change to a decimal is about 17 cents. Give me a thumbs up if that's okay. Give me a thumbs sideways if we're pissed about it.
Is that 17?
Are we pissed about it? We're pissed about it. Okay, let's throw it up on the screen. So, you can't see that. Now you can see it. So if we just Google 1 times 6/36, it's going to be the decimal 0.1666666. Since it's a dollar, it's going to be that many cents. So we just rounded it off to 17 cents. That's all. Don't overthink it. It's just multiplication of fractions, changing it to a decimal. Don't overthink it. I know it's easy to do that in a math class. It's very easy to overthink it. I get it. Trust me. Okay? Ah! Negative $1 times 18/36. What do you get? 0.5, right? That's a half. Times 1 is still a half, except it's negative. So that's a loss of 50 cents. Scheisse. As our son is always saying. And last but not least, what is 0.5 times 12/36? What is 0.5? Oh, Brady, ask me that question.
The light bulb on the one, was that, what is that?
Payout times
Notice right here, payout times probability. I just shorthanded it, Brady, from over here, multiply each payout times probability. Just try to shorthand it a little bit, is that okay?
Yes, thank you.
Appreciate you, great question, great question.
Sorry.
Why? It's a great question, come on now. All right, math. 0.5 times 12 divided by 36. What do you get? Use your phones, use your calculators. Don't do it in your head, for God's sake.
117 cents.
It's the same as the top one, actually. Because this is half of this, but this is double that. So it ends up being the same thing. It's 17 cents. Make sure you can get 17 cents. 0.1666666. Repeating forever. Which rounds off to 17 cents. I know. Joe was like, these damn dice. And now, we have one last thing to do, and it's very quick. What do we do with those three numbers? Somebody just say it louder. You add them up, Andrea, because remember what Jessica told us? You add up all the data and divide by how many data points you had. Here's the good news. You already took care of the division with the probabilities. You did the division already. All you gotta do now is the addition part. So that's step 4. Add up the results of 3. That's the expected value. That's the expected value. So let's do it. Oh, don't forget that's negative. Shit. I wish it was 84. I wish it was 84, huh? That'd be nice if it was. But it's not. Because that's negative.
Minus 16 cents.
So it's, isn't it negative 16 cents? Isn't that what it actually is? Negative 16 cents, right? Shit. So what does this mean?
Lose.
You're gonna lose on
Average.
average. You're not always gonna lose, right?
Probably.
If you keep playing this game, effectively, it's like handing the dealer 16 cents every time you walk up. Just take the 16 cents. Just take it. That's really what's happening. Can you ever lose 16 cents playing this game? Can you ever physically lose 16 cents? You can't. You either win $1, lose $1, or win 50 cents. But because of the way the payouts are structured with the results, you end up losing on average. You win half the time and you lose half the time. Probability-wise, you win half the time and you lose half the time. The problem is, the half the time you lose more money than the half the time that you win, which makes the game great for the casino. It's a fantastic game for the casino. You buying this? Is it close to what we got? We got a loss of 21 cents. Anybody pissed off about that? Ours was a little bit lower. Is anybody upset about that? I would ask Avery if you got a poker face and I can't read it. I can't tell if you're pissed or not. You might be pissed. A little bit pissed? No, maybe, I don't know. Maybe not. No, you shouldn't be upset. Why? What's that based on?
121.
120 games we played. This is based on the theoretical probabilities of what happens with dice. This is close. If we kept playing, we'd see this 16-cent loss show up. All right, you badasses, right now, practice. Do Dame B. Do Do game B's expected value in the space below. Follow the steps, they're right here. The steps are right here. Make sure that camera can zoom in on those steps. Yes. Yes. Oh, you can see it pretty well. That's actually pretty good. Yeah. Do game B, establish the probabilities. Should I put the outcomes back on the board for the dice? Would that help, Malaya? Is that good?
No.
We like that? Should I put the outcomes back on the board? There they are.
What were the rules for game?
Ah! What were the rules for game B? If you rolled a prime number, you won $1. Otherwise, you lost 50 cents. Thank you, Travis. I forgot we took that away from you. I know it written down anywhere. What did he? If you, I'm gonna add that back to the note sheet for next class. Thank you for letting me know about that. I appreciate you. Yes. Because look, tight. I'm gonna freeze the screen. I'm gonna put that on the note sheet right now while I'm thinking about it, because I will forget. Because, well, you've met me. Oh, it's week 3. You lost the opportunity to get your money back in the class. You mine now.
5 in 36 chance. It's different because each one has a separate, multiple ways to get it.
Oh, 2.
So unless you get $1 if you roll a prime number,
Yes, you win $1 if you roll a prime number.
and anything else.
Anything else, you lose 50 cents. I'm gonna put that, yeah. So prime equals win $1. Anything else, lose 50 cents. Fair? That was the rules for the warm-up. I'll put that in those documents right now. Thank you for. Thank you for that, Travis. Ask me to repeat that. And Angelina for asking me to repeat it too. Appreciate it.